Saxon Math Course 2, we are in Lesson 37 today, and we're going to be studying two things, but one primary one, which is the area of a triangle. In your text, they give a couple of important facets of a triangle. I'm going to try to draw a right triangle that looks somewhat good here. Okay, they're going to call this the base of a triangle, and then this height is obvious. All right, so we have base and height. What I want you to note in a triangle is that if it is a right triangle here, we're missing exactly half of it, correct? So if I kind of scribe in with red the other half, it's basically one half a rectangle or one half a square. So it brings into the math a equation that is this. It would be base times height divided by 2. You might also see it like this. It may look like this. 1 half base height, right? 1 half base height just means the same thing as base times height divided by 2. And you're going to see kind of the equation here. Both of these are equal, okay? All right, there's a couple things to remember, okay? If you have a triangle that looks kind of like this, all right? We call that a scaling triangle where all three sides are different in their height. Okay? How do you find the height of a triangle? Well, the height is still its highest point all the way down to its lowest point, even though you don't see that as part of the triangle. Okay? This triangle is still 1 half base times height, even though it looks like it's missing more, okay, than it is. Because you can also get the height of this, which we're not going to do until geometry. But if we know the height and we know one of the bases, we can divide it by 2 and we will be able to find the answer to that. Okay, so let me do an example based on your textbook. Let's go to example number 1, and that's going to skip over to 267. And we're going to have a triangle that is exactly kind of like the one I just suggested, where it's not exactly a right triangle. And you're going to see here that they've got a dotted line drawn here. And I'm going to fill in the numbers. They say that the height is 4. They give the hypotenuse as 7. And then the base down here is 5. So what do we do with those numbers? Okay. Well, what is the base? The base is what's sitting on the shelf, right? So if this triangle is sitting on the floor or shelf, 5 is the base. So we're going to say 5 times, well, what's the height? 4. Well, you kind of want to multiply it by 7 because it's the biggest one, but that's not what the formula says. So it's 5 times 4, which equals 20, and we know we divide it by 2, which in this case equals 10. Here's another way to do it. 1 half base times height. Okay, so if we have base times height, which is 5 times 4, and we multiply it by 1 half, which is the same as dividing it by 2, okay, we still have 10 for our answer. Pretty easy. Okay, example 2 gives the same thing, where it gives a 30, 60, 90 triangle, which looks like this. A little bit easier to see because it's a right triangle. 3 and 6. Well, what's base times height? It's 6 times 3 equals 18, but then we have to divide that by 2, so our total is 9. 18 actually represents the area of this. 18 is the total, and half of that obviously is a triangle. I think you understand. All right, one more little idea here. Part 2 of this lesson was dealing with a rectangle that doesn't have, or a square that doesn't have all of the square there. And we're going to find the area of this. Okay, so I want you to look at example 3, and I'm just going to do one of them because they're relatively easy once you see what happens here. Okay, so it's going to ask us for the area of this whole thing. Well, notice this. This is what we don't have. Okay, we don't have it filled in right here. Okay, just this little box is missing. Okay, and I'm going to draw lines through it just to show you that we don't want to have that as part of our answer. Okay, I want you to note something. Okay, this line over here and this line over here all the way down, okay, is equal to 12. So we know that from here down it's equal to 7. So what's 12 minus 7? What does that equal? Well, we know that it equals 5. So we know that this little spot right here from here to here is equal to 5 because 5 plus 7 is 12. Let's figure out what this is. Right? We said that the whole thing is 13 and this up to this point is 10. That means this has to be 3. In other words, 13 minus 10 gives you 3. So we know what these two sides are. Well, 3 times 5 is 15. So the area of this little square right here is 15. Now we can find the area of the total thing. In other words, we can multiply 12 by 13 and we can get the entire thing, and then we're going to subtract this 15. Okay, so let's do the math here, and we note that it's 156. We're going to subtract 15 because we don't want that little square in there, and we come up with 141 feet squared. All right, so that's how we get that answer. And there are several problems in your textbook that give that kind of idea. I always find the total, and then I find the little guy and subtract the two. All right, pretty simple, and I know you guys won't have too much problem with that, but I just wanted to show you how to do that, and that's part B on lesson 37. All right, if you have any questions, let me know, and I'll be willing to help.